So here the diagram shows the curve y is equal to 6x plus 2 the whole raised to 1 by 3 and the point A12 which lies on the curve. So you can find point A12 on the curve. It is here. Yes. The tangent to the curve at A cuts the y-axis at B and the normal to the curve at A cuts the x-axis at C. The tangent cuts y-axis at B. So you can find the point here. The tangent cuts y-axis at B. The normal of the tangent cuts x-axis at C, this point. Okay. So our question is, find the equation of the tangent AB. We have to find the equation of tangent AB and the equation of the normal AC. It carries 5 marks. Second question, find the distance BC. The distance BC you have to find out. For that we need the coordinates of B and C. Next question, find the coordinates of the point of intersection E. So we want the point of intersection E. Okay. Which is the point of intersection of OA and BC, and determine whether E is the midpoint of OA. So these many questions are there to do for this. Let's find the answers. So in this question, the equation of the curve is y is equal to 6x plus 2 the whole raised to 1 by 3. And the tangent, AB is the tangent, meets the curve at A. So the point of contact is A, 1, 2. But we do not know the gradient of AB. Once we know the gradient of AB, we can use y minus y1 is equal to m of x minus x1. So let's find the gradient using y. Y is 6x plus 2 the whole raised to 1 by 3. Here to find the gradient, use dy by dx. Remember, here we cannot use y2 minus y1 by x2 minus x1 because we do not know 2 points on the line. Okay, so when you differentiate it, we get 1 by 3 of 6x plus 2 the whole raised to 1 by 3 minus 1. That is 1 by 3 6x plus 2 the whole raised to minus 2 by 3, and that should be multiplied with 6 because internal differentiation. So that is multiplied with 6. So when you do the operation with 6 and 1 by 3, we get 2. So 2 of 6x plus 2 the whole raised to minus 2 by 3. That is dy by dx. Now at the point A12, that means at x equals 1, we get dy by dx changed to gradient is 2 of 6 times 1 plus 2, that is 8 raised to minus 2 by 3. That's equal to, what do you get? 2 into 8 raised to minus 2 by 3. What is the answer of 8 raised to minus 2 by 3? 8 raised to minus 2 by 3 is 1 by 4. That is 1 by 2. So the gradient of the tangent is 1 by 2 and it passes through the point 1, 2. So gradient is 1 by 2. Now let's find the equation of tangent AB. So the equation of the tangent is y minus y1 is equal to m of x minus x1, which is y minus 2 is 1 by 2 of x minus 1. That is y minus 2 is x by 2 minus half, or y is equal to x by 2 minus half plus 2, or we get y is equal to x by 2 plus 1.5, 1.5 as equation of tangent. So equation of tangent is y is equal to x by 2 plus 1.5. Now we have to find the equation of the normal AC. Okay, as we know, the tangent is perpendicular to normal, or normal is perpendicular to tangent. m1 into m2 is equal to minus 1. By using that concept, we can get the gradient of the normal AC, and the point is 1, 2. So with the help of those two concepts, we can find the equation of normal. Normal AC is also passing through the point 1, 2, and here AB is perpendicular to AC. So we get m1 into m2 is equal to minus 1. m1 is the gradient of the tangent that we got already as 1 by 2 times m2 is equal to minus 1, or m2 is minus 2. Now to find the equation of the tangent, use the formula. So the equation of normal, y minus y1 is equal to m of x minus x1, that is y minus 2 is equal to minus 2 of x minus 1. Y minus 2 is equal to minus 2x plus 2, or y is equal to minus 2x plus 4 as the equation of normal. So this is equation of tangent, and the equation of normal is y is equal to minus 2x plus 4 as a result. Next question is find the distance BC. So to find the distance BC, we must know the coordinate of B and the coordinates of C. And here it is clearly given that B is a point on y-axis. And you know, on y-axis, x coordinate is 0. So we can assume B as 0, y. And C is a point on x-axis. And you know, on x-axis, y coordinate is 0. So assume C as x 0. Okay. Now when you consider B, B is a point on the tangent also. So what is B? B is a point on the tangent. So let's take the equation of the tangent, which is y is equal to x by 2 plus 1.5. And B is a point on the tangent. So when you replace x and y with these points, we get y equals 0 by 2 plus 1.5, or 1.5. That gives us the value of y as 1.5. So we get y as 1.5. That means the point B is, that implies the point B is 0, 1.5. Now similarly, we have to find out the point C. So when we consider the point C, look at the point C, it is a point on the normal. So to find the point C, you have to take the equation of normal, which is y is equal to minus 2x plus 4. And when we replace the value of c with x0, we get 0 is equal to minus 2x plus 4. When you simplify it, we get the value of x as how much? 2. So the point C is 2 0. So we got the point C as 2 0 and B as 0 1.5. Now we have to find the distance BC or length BC. To find length BC, let's use the formula root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to, and our points are B 0 1.5 1.5 and C 2 0. So when you replace the points, we get square root of 2 minus 0 the whole square plus y2 minus y1, 0 minus 1.5 the whole square, that is square root of 4 plus minus 1.5 square is 2.25. So we get it as square root of 6.25, which is equal to 2.5 units as length of BC. So we could find the value of BC as 2.5 units. Next question is, E is the point of intersection of OA and BC. We have to find the coordinates of E and verify or check whether this point is the midpoint of OA. Okay, so our first topic is to find out the coordinates of point E, where E is the point of intersection of BC and OA. Okay, so let's see how to find the answer for this question. So here our plan is to find the equation of line OA and the equation of line BC. So we get two linear equations and consider those two linear equations as simultaneous equations. Solve those two equations using elimination method. So that's our plan. So let's find the equation of OA and BC. So OA is O00 and A12. So if you find the gradient of OA, it's y2 minus y1 by x2 minus x1. That is 2 minus 0 by 1 minus 0. That's equal to 2. Okay, so our equation of line is y minus y1 is equal to m of x minus x1. That is y minus 0 is equal to 2 of x minus 0. You can take any one of these. Okay, so we get y is equal to 2x as the equation of OA. And when we consider the next line BC, their m is y2 minus y1, that is 0 minus 1.5 by 2 minus 0. That is minus 1.5 divided by 2. What is the value for this minus 1.5 divided by 2? Which is minus 3 by 4. So y minus y1 is equal to m of x minus x1. That is y minus 0 is equal to minus 3 by 4 of x minus 2. If I take this one as the point, you can take this point also. To avoid this decimal, I have taken this point. It's your convenience. Okay, So when we expand the bracket, we get minus 3 by 4 x plus 3 by 2, because 3 by 4 into 2, 2 and 4 get cancelled. So this is the equation of line BC, and the equation of line OA is 2x. And when you check these both the equations, they both have y as a common term. So it can be written as 2x is equal to minus 3 by 4 x plus 3 by 2. So when you arrange the terms of x in one side, we get 2x plus 3 by 4x is equal to 3 by 2, or 2x plus 3 by 4x. What is 2x plus 3 by 4x? That is 2.75x is equal to 3 by 2. 3 by 2 is also same as 1.5. So that we get x is equal to 1.5 divided by 2.75. That is x is equal to, what is 1.5 divided by 2.75? So we get this answer as 6 over 11. So the value of x is 6 by 11. Now let's find the value of y. Just by substitute here, we get the answer. So value of y is 2 times 6 by 11, that is 12 by 11. That means the point E is 6 by 11 and 12 by 11. Okay. Now you can check whether the point E is the midpoint of OA by using midpoint formula. Next question is the line y is equal to x by k plus k, where k is a constant, is a tangent to the curve for y is equal to x squared at the point P. So here y is equal to x by k plus k is a tangent to the curve for y is equal to x squared at the point P. So point of contact of curve and the straight line is P. Our first question is to find the value of k, and the second one is the coordinates of P, which is the point of contact. Okay, so for this the first target is how to find k. Let's see how to find the value of k. So as per this question, the equation of the tangent is y is equal to x by k plus k, and the equation of the curve is 4y is equal to x square. So let us make one rough diagram. We have a curve which is 4y is equal to x square, and there is a tangent at a point P. The equation of this tangent is y is equal to x by k plus k, and the equation of this curve is 4y is equal to x square. Okay, now the first question is to find the value of k, and let's find the gradient of the tangent, and here also gradient of the tangent. So when you consider this question, it is in the form of y is equal to 1 by k x plus k, in the form of y is equal to mx plus c, so that the gradient is 1 by k. Okay, now let's find the gradient of the tangent by differentiating this equation. So we get y is equal to x squared by 4, or dy by dx is equal to 2x by 4. Now what we need is the value of x. So we get it as x by 2. Now this both defines gradient of the tangent. So we can decide x by 2 as 1 by k, or x is 2 over k. So we get the value of x as 2 over k. Now what happens to this equation? We get y is equal to x is 2 over k by k, that is 2 by k squared plus k. And what happens to this equation? For y is equal to x squared, and x is 2 by k, so x squared is 4 by k squared. 4 and 4 get cancelled. We get y is equal to 1 by k squared. Now this equation has left hand side y. This one also has the same left hand side. Yes. So we can write it as 2 by k squared plus k is equal to 1 by k squared. When you take the LCM, we get 2 plus k cubed by k squared is equal to 1 by k squared. K squared and k squared get cancelled. We get 2 plus k cubed is 1, or k cubed is minus 1. That implies k is cube root of minus 1. Cube root of minus 1 is minus 1. So we get the value of k as minus 1. Now let's find the point P. Now it's very simple to find the point P. As k is minus 1, this equation become y equal x by minus 1, that is minus x, plus k, that is minus 1. So we get y is equal to minus x minus 1, and here y is equal to x squared by 4. So when you combine these two equations, this is a non-linear equation and it is a linear equation. So there are two equations. There are two simultaneous linear and non-linear equations. So when you do it, we get x squared by 4 is equal to minus x minus 1, or x squared is equal to minus 4x minus 4, or x squared plus 4x plus 4 is equal to 0. Now we got a quadratic equation, solve it, we get the value of x as minus 2. Actually there must be two values for x, but here we got only one value because the roots are real and equal, as b square minus 4ac equal to 0. So we get the x coordinate of the point P as minus 2. Now you know how to find the value of y, which is, y is x squared by 4, that is minus 2 squared by 4, which is equal to 1. So the point P is minus 2, 1, and k is minus 1 as results.